Hello. I wanted to show you the robot from before we worked on and got right into the ultrasonics and the infrared obstacle detector and a lot of detail right up front. But the robot itself that I'm building, which is actually working out better than a robot that I've purchased a couple of frames. Actually, one frame in particular that hasn't worked out. It doesn't, and I'll show it later also. But it hasn't worked out because it's just a little too frail. It's a little too fancy. Where this one here, that what you're seeing, is let me detail it a little bit. We have a 1 foot by 1 foot base plate. Now this is an aluminum plate that I bought on eBay, and if you just search on aluminum metal plate, you'll find it. And I think it was about $11 for it. Expensive for a little chunk of aluminum that you feel like you could find anywhere, but it's perfect. It's there's no burrs. There's no burrs along the edge. It's been milled off good and very strong, and it's easy to drill through too, which surprised me a little bit. It is thick. It is thick along here, and it's easy to drill through, even though it is thick. I guess being aluminum. And let's look at one of the wheels. The wheels, well, I call them wheels. These are, I really don't know what they are. They were used in this original motor. Here's the motor, the gear housing. Here's the motor, and you have a ratio. I don't know what the ratio is of what this is. It's probably 100 to 1 or something. It turns very slowly as compared to the motor. These I bought at a junk store, a surplus store, electronic surplus store, and for probably $7 each. I think they're actually still marked at $7.95 each. But that was quite a while ago, and I have actually not, even though I said I've seen something similar, I've actually not seen anything exactly like this on eBay. I've looked because I wanted some more of these, but I couldn't find them. I found the motor gearbox part and the motor part, and the two sometimes come together, but that's all I found. Now, so anyway, if you can find a motor, a wheel mount that will mount onto the, where you have to couple it or whatever to the shaft of the gear box, which is what you'd have to do. I'm not sure of. I'm actually not sure of. I have found plenty of gearboxes and plenty of motors, and then you can couple them together, and so I just assume you can find some wheels out there that will fit. But it might take some trial and error. You might have to buy 2 or 3 different sets to get the right sizes to fit. But anyway, how I put these on was some good old Home Depot angle brackets, that you mount shelving on the wall or something like that. These angle brackets here, let's get a little better view. These angle brackets here, just ones you can find at Home Depot, are very nice for something like this. They're very cheap. They're like $1 each or something, maybe even cheaper than that. Excuse me, I've got some sort of a hay fever has hit me all of a sudden. And as you can see here, I've got them where they come over. They're mounted on the aluminum metal base, and then go downward to about right here. Then this motor gearbox is mounted onto the angle bracket here, and I've got a little bend upward just because of the force of the weight and the force of the rest of the weight on there, but it seems to be okay. It's not hurting it. This screw hole, this mounting point here on the gearbox is currently not actually screwed into anything. There's nothing. It's not being used. It's the only one I'm using is this bottom one here, so that may be part of the problem. But you know, that's when you're trying to get things to fit. That's what happens. And one of the interesting things about this is there's the wheel section right there. So that was some sort of a turntable, or I don't know, something. I never did figure out what it really was. Now if we move over, excuse me. If we move over to the middle, to the this is as I think I showed a little bit of it. This is the motor control board. Here's the big motor control IC that's used on this. This is an Arduino motor control board. Arduino. Motor control board is their original one, or one of their original ones. There is code out there, as I had shown in the previous video. There is code out there that you can find to use it all. Although it didn't look that difficult, I think I could have figured it out. But you know, the code's out there, and so why not use it? We're not interested in reinventing the wheel here. And so I've got the wires coming over from both motors, going to the motor control. This one coming over here from this motor to the motor control. And then the battery back here, as you can see, I've got it wired in and just jumbled around with some jumper wires. I don't quite know what to do. As you can see, this is the negative and the positive coming from the battery, and so I've got some jumpers coming from it, because I don't quite know what to do with these yet. Whether I'm going to put them in. Well, let me show you. Let me show you where I think I'm going to mount them. These right here, as you might be able to read there, I'm not sure. Is that readable? 5 pieces, dual row. I'm reading them on the little screen here. Dual row, trip red, black, 6 pieces new. I don't know. Okay, maybe that wasn't worth reading. But these are terminal blocks I'm going to use. I'm thinking this is the only way I'm thinking we can. Here's a terminal block. Oh, brother. Terminal block to use, you know, where I'll put in the red wire. I'll put in the red wire on one side and the black wire on the other side, and then I can branch everything off of there. And so, well, you need, if you put the ground here, you'd like all of these to be ground, so that you can branch off of it, or I mean, you can take off of that and use that ground in different places. It's, you know, it's a multiplier. Well, these come along. This package comes along with these right here, and so you end up just basically clamping these into here. I'm trying to get that plastic. There we go. These end up going into here, getting screwed in. You put your ground here, and then it gives you 1, 2, 3, 4 grounds. Plus, you can combo your ground with any one of these. You can put 2 or 3 grounds on underneath the same screw terminal. But you get at least 4 nice grounds that come off of there. And this is very handy for making one side or one terminal block all ground. And then you do the same thing with the plus 12 volts or 11.1 volts, whatever it is, with this particular battery that I've got, this LiPo battery. And put the red on one side, so I'll have one terminal block dedicated to the ground and one dedicated to the hot. And then you can branch off of there, and I can go to these nice. I bought a 10 of these power supplies. Let me show you these. Now I don't have these mounted right now anywhere. I'm just using them on the bench. But this, I'm sure you've seen these. These are buck converters. They convert a higher voltage to a lower voltage, but they're very nice. They're very efficient, and they just show the direction. This is the in voltage. This is the out voltage. Right now, I've got the LiPo battery coming in here on my bench. I don't have it on the robot. Don't need it right now for the robot. LiPo battery coming in here, and then out here comes out 5 volts or whatever I want to adjust. And these you can find on eBay for pretty cheap, for just buck. If you put in buck power supply, you'll get about 2 or 3 dozen of this type. And I bought several different types. This one is the best one just because of ease of use. And you just want to make sure you get a nice big fat inductor. Even on their picture, you want to be sure and read the description of it, and make sure that, this one says it starts getting hot at around 1 amp or 2, which is probably right, given this has no heat sinking or anything. But you got a nice big fat inductor. So we're going to produce some current. Now the capacitors aren't all that big. But let me look at those and see what the value of those caps are. Hang on. Excuse me. This one is 50 volt, 100 microfarad. The output, that is the output, yeah, that's the output, is 25 volt to 20 microfarad. So they're not all that big, but that's fine. They do the job. I have measured ripple on them. I haven't shown that, but I measured ripple on them. I hooked them up to a DC output out of my power supply, and because it was clean, so there really wasn't any sense. And I just wanted to see if it was more introducing ripple rather than trying to suppress ripple, because I have a nice DC output power supply, and so it was putting out a very low ripple, or at least it wasn't introducing any ripple. The voltage was adjustable, just as the instructions said. I could go down to about 1 volt, 1 volt above the input, all the way up to, the maximum amount. I'm sorry, 1 volt below the input, or the output, down to the value where it would drop out at. That didn't make any sense, did it? Well, I have to sneeze first, and then I think I can think, unless my brain flies out. Anyway, I put 12 volts in. I can go up to about 11 volts, all the way down to, all the way down to 1.3 volts, I believe it is. So they're a good buck converter, and I didn't mean to go on and on about those. I am impressed with those though, and I bought 10 of them for $13, I believe. Now let's see. I think we've covered the robot here. We've gotten the two wheels. We've got the motor controller. It's the Arduino, the Arduino, the original Arduino. You can't buy it anymore. You buy their new one. They have a new one out that's probably better. The one thing I don't like about it is they put these interfaces on the side here, and these can go off to other type of inserts like sensors or something. But I don't need that. I would rather these just be my Arduino outputs. So I'm kind of having to steal the pins off of there, which is not very easy to do because they've shortened the pins. And anyway, I would rather have it where we're just a normal Arduino pin structure up here. But anyway, I can make it work. And the battery. For you battery guys out there, I'm going to show his little brother here instead of untaping it. It's the same thing as Turnigy, which is just fantastic. I can't say enough good about Turnigy. Their batteries, their battery chargers are reasonable and very reasonable in price. I got the battery charger for $24, I believe, which charges these and other types of batteries, multi-chemistry. And this one is the 11.1 volt. It's 3-cell, 2200 milliampere hour. It's a 20 to 30 C, but I don't really care about the 20 to 30 C because I'm not looking to discharge it at that kind of quickly. With that kind of speed, but here's your main input for charging, or your output for running through your project. This is the monitoring cables and the balancing cables for the charger. You can also I purchased but haven't received yet a little monitor that you plug into here, and it will buzz when your cell gets down too low. Your 3 cells get down too low, a little buzz will go off. I can't wait to get that, and I'll show you when I do get that. But anyway, and let me show you this. Let me show you this charger because it's worth it. It's worth getting. If you need a charger, this Turnigy AccuCell is worth getting. It is a very nice one. We don't have it plugged in, but you plug it in. That's what turns it on, and then you pick your type of battery, and then it'll do a lot of auto checks on it, and then you start the charge on it. You plug in your monitoring. This cable here. You plug that one in there, and then you plug this one in here where the two, you see these two fat black and red wires are, and you can end up with a nice. This is about $23 for this charger. This I believe I paid $15 for, and this one back here I think I paid $20 for. So you end up with a really nice charging battery charging set for not that much money. I mean, anyway, so this is the base of the robot with the aluminum plate and the wheels, the old sweet Arduino, and you saw it running around on the floor. And I'll show more of that as we go along. But I just wanted to give you a little background as to what the base of this is and what it's made of. And it's Home Depot parts, scrap bin parts from an old surplus store, and then some really cool battery stuff from Turnigy, and then some old Arduino parts that are no longer available. But they have new stuff that replaces it that's, I'm sure, even better. They'll have more code out there, that's for sure. It took a while to find the code for that. That's what I do. I look first for if somebody else has written code for it. Hopefully they have. If they haven't, then I write it myself. And I'd rather find somebody else's code than just modify it to use. I'm more interested in it, getting it working and getting it going than I am in actually fundamentally writing each line of code. Although I do like writing about a third of the code as mine to add to what I have found. I don't know what you'd call it, philosophy. Maybe that's a lazy philosophy, but that's my philosophy anyway. And all right, well, that's the base of the robot, and now we'll look at something else here and see where we go from there. I hope that hadn't got any of those weird lines in it. If it does, you may not see this if it does, because I know those things will just ruin it. But this is the laser module that I use, that I talk about so much, that I kept mistakenly calling a laser rangefinder. It's not. This is the laser module, and I bought another one. Although they were supposed to send me two, I ordered two and paid for two. And I ended up getting one. Let me just show you the real thing instead of a picture. There's the picture of it, and there's the real thing right together. You can't tell the two apart, can you? And this is the lens system, as you can see, which collimates the light down to the, I don't know if that's a true term or not, but gathers the light, focuses on the lens. There's the back of it, back of the lens. I mean the sensor, not the lens. It gathers the light, focuses it on the sensor, and here's the laser that comes out and acts as the the scattering of the light that it's going to detect, the infrared light. And then the chip they've got, actually that doesn't look like, there it is, a little tiny thing right there. I don't think you can even see that, and my camera's not going to focus in on that. Sorry about that. But that is supposed to be, at least according to their instructions, according to their website, they're supposed to be oscillating, and then it detects the oscillations, and they've got it tuned for that, so it's easier to pick up that infrared no matter what the lighting conditions. But here's the website. If you want to buy one, I highly recommend it. I have no affiliation with these folks, but I highly recommend buying it. It's a laser sensor detector module receiver transmitter for Arduino ABR PIC application for obstacle detection, pipeline counter, smart robot obstacle avoiding cars. So they've covered everything there for their search terms, as you can tell. You just go down the list here, or down the page, and not see anything too interesting down on this one. Not see anything interesting at all. WaveShare laser receiver module, laser sensor module, transmitter for the Arduino. Anyway, that's the one that I bought, and it really works well. That's the one I would go for. And I don't see any other detailed description of it. I don't know where I got that 340,000 cycles per second. I thought it came with a little explanation came with the board, but no, I don't know. I might have been going crazy when I said that. But that's it. That's the board. Rather, let me show you there. There's the text of it. If you want to buy one, they're $14 each. They're expensive, but if you really want to detect an obstacle about 2 foot, 3 foot in front of you, and for sure, whether it's dark or bright sunlight, this will do it. All right. The one thing I forgot was the caster. The little caster wheel you put on there, and that was from Home Depot too, and works great. Anyway, I thought I'd show you that. Well, I thought I'd let you in on the fiasco going on here. Okay, this is the motorboard that was on the robot that I showed you. It's an Adafruit, one of their original ones. It works great. It's got a nice size heat sink. I think it'll be fine for long term. I let the robot run around on the carpet, you know, as you saw in the earlier film or earlier video. I just let it run around. It doesn't get hot, so I think he's going to be fine. However, it's got these Adafruit put these extra connectors along the sides and the front here, and these extra connectors are for their sensors, or on the documentation even it's servo motors, but they're 4-pin connectors. I can't get that close enough, it's too blurry, but they're 4-pin connectors, and on the servo motors are 3-pin connectors, so I'm not sure what servo motor they're talking about. Maybe it's one that they have. But I've got so many servo motors, I don't need any more. And so the reason why I had to pull this off is because I was, if you remember in the first video, I was talking from the ultrasonics board, which you can hear over there. If you hear that, that's what that is the ultrasonics is moving on a servo motor. I had that talking via UART from the mega board over to pin 6, which is going to be, actually turn this around, pin 6 over here, which I'm using soft serial from the IDE, from Arduino IDE. I turned into a receive pin, and I was sending data over, so that was successful. But there's no good wire interface. I mean, I could, as you saw me do before, I could bodge a wire here and solder it here. I could solder it over on top of this connector, but I don't want to do that. I want this to look somewhat neat and be, since this robot's going to be running around and running into things, I don't want the solder joint to crack on it eventually, which it probably will if I do that. But if I solder it in there correctly, it will be, I think it'll be fine. Now, this motor board is a good one. You have your main input power here. This is where the LiPo battery comes in. And then you have a plus and minus for your left motor and plus and minus for your right motor. And they have a very simple interface. You just tell it to enable one of the motors, and then pulse it for left or right, and enable the other motor and pulse it for left or right. So they've got a really good system in this. I just don't like all of these. They put these in for sensors, and it would interface to an Arduino. I can see why they did it, but for me, for my purposes, it doesn't work. So what I'm going to do is desolder these connectors along here, at least a couple of them anyway, so I can get easy access to those. They would be pin holes at that point, and so I can just solder in my pins and my wires and have a good solid connection. So anyway, I want to let you know where I was with that. I had to disassemble it, and in order to make a good UART connection, going to have to get rid of a couple of these connectors so that I can solder in my wires. Well, this is what it's come to, is I don't have my solder sucker, and I cannot get, this is not showing up well. I'm going to get better lighting, I promise, but one of the connectors here I took off just by snipping the pins off and then trying to desolder the pins that went from the connector down into the board, and I didn't do a very good job of that because I don't have I have wick, you know, good old standard wick, and that didn't do the job. This stuff, that didn't do the job. That just took the surface off, the surface of the solder off. So I need a pretty good solder sucker to get that off. I apologize for the darkness of this. I'll fix that. But anyway, the connector goes there. It's got 4 pins, and they're not coming out. What's left of the pins is not coming out. So I'm buying, or I have purchased on eBay, this Greenlee PA 1700 desolder standard with a standard tip of 0.18 inch. The Greenlee, I bought this not because I know this particular solder sucker, but I know the company Greenlee. I actually worked with them for 6 months as a consultant, and doing something completely different. Had nothing to do with, it dealt with computers, but it was software. It was not hardware. So I know Greenlee, and I know they make very good products. So that's why I'm going ahead and purchasing this one, even though it's a little bit expensive. It's $29.99, free shipping. But $29, I don't know. I've never spent more than $10 for a solder sucker. Maybe that's why I don't have mine. Maybe I haven't been paying enough. But I'm going to try it. I'm going to give it a shot. It's supposed to be a really good one. It's got excellent reviews, and we'll see if it does good. But I'm going to have to wait now 4 or 5 days for the solder sucker to come in before I can desolder the pins out of the pins that I left in the board when I cut them. And I can't get them out in any other way, so that I can put it back on the robot. But there's plenty to do in between now and then. As you've probably been hearing, Mr. Reliable over here has been reliably scanning the room as he does, and I'm just running him through almost like a burn-in test, you might call it. I just want to see if he fails with something or falls apart. Nothing's getting warm. The motor inside the servo is not getting warm. The wires seem to be okay. I'm going to leave this little frazzly hairdo on him. I am going to clean up the wires when we get on the robot, and they'll be tie wrapped down. But I think I'm going to leave him pretty much as is. He's doing a pretty good job, and I'm burning in a power supply, which I'll be using currently right now. When I say burn in, I mean I'm just putting through about half the current that would be maybe required of it over a long period of time through a couple of days, just to see if it fails, because I don't want to go through the trouble of mounting one of these things, these power supplies, mounting it, and you know, you drill the holes for the size of the holes that are in the board. You drill the holes in the aluminum and all of that. I want to make sure that it's gonna last. So for a couple of days, I'm putting it on burning half an amp through, which is a little more than what I'm going to ask of it on average. And anyway, that's one thing that's going on while curly haired here, mullet head is doing his thing. So I've still got things to do. I've worked on the program some more, and that sends the data from the ultrasonics to the motor. But now I kind of got distracted with the getting a better wiring solution over there, and so what I'll probably do next is work more on the program to get the UART talking over there, because I can still hook him up and still have him talking to the UART, through his UART to the ultrasonics, and get that going. I can still do that without him actually running motors. I can just, and without actually having those pins, I can just tack on something real quick to do that. So that won't stop that. Okay, all right. See you later.